Look at all of you. So today we are going to perform the titration experiment. Okay na? So what we call this one as burette. What we call this one? Burette we'll call. Okay na? So this is burette children. So what we call this one as stopcock. What is this one? Stopcock. So if you release this one, so inside this burette kmno4 is there. What we call this one? kmno4, potassium permanganate. What is this one? Potassium permanganate. So this will fill and will give for you. So this potassium permanganate will fill. Okay na? So there potassium permanganate is there. Lastly bring that one. Harika. There potassium permanganate. So starting while we are doing is, you observe here clearly. So the starting reading is 0 and the ending 0 is 50 here. Are you understanding? So from starting we'll fill this one. Okay na? So we'll fill and we'll give for you. Okay na? Potassium permanganate will fill and will give for you. So this is the potassium permanganate. So slowly have to fill. So up to 0. Up to 0. Exactly 0 is there here. Okay na? Exactly we'll fill and will give. Okay na? So this is a potassium permanganate will fill. Okay na? Listen carefully. So this is what we call this one as stopcock. What we call this one as stopcock. What is the use of this stopcock? This stopcock, what is the use means? To release the potassium permanganate, and immediately if you want you can stop also. Okay na? This one slowly have to move. If you move this fast, this kmno4 will fall down very fastly. Are you understanding? So that's why this potassium permanganate, while releasing, you have to release it slowly. Clear? Right. Next, this is conical flask. What we call this one? Conical flask. You can observe here this one. This is the conical flask. Okay na? So in this conical flask, see all of you the material, see, procedure, see. So what we are doing here, the experiment is estimate the molarity of kmno4 solution using standard FAS solution. We have to find the molarity of kmno4 solution by titrating it against what? FAS. What is the meaning of FAS? FAS means what? Ferrous ammonium sulfate. There you write ferrous ammonium sulfate. FAS means ferrous ammonium sulfate. This ferrous ammonium sulfate will also call it as more salt. MOHRS. MOHRS. More salt also will call. Clear? So now you can observe here. Look at here all of you. Already we have prepared this FAS solution. See, light green is there. Are you seeing, children? Light green is there. This is ferrous ammonium sulfate. We also call it as more salt. What we also call it as more salt. The formula is NH4 twice, FeSO4 twice, 6H2O. So this is the formula. Okay na? Right. Now look at here. Look at the procedure, all of you. First, this what we call, children. This is pipette. What we call this one? Pipette. You already studied in the first chapter some basic concepts of chemistry. These are all used for measuring the volume of liquids. If you want to measure the volume of liquids, there are some instruments. What is this instrument? Burette. What is this instrument? Pipette. So these are the instruments to measure volume of liquid. So now if you observe this burette, children, how much volume it can measure? 50 ml. See here the 0 is there starting, here 50 is there. Like there 100 ml burettes will be there, 200 ml burettes also will be there. Are you understanding? So for measuring the volume of liquids, we use these instruments. Now look at here all of you. This is called pipette. What we call this one? Pipette. See, observe here how much ml is there? 10 ml is there. So this is 10 ml pipette. Observe here carefully, students. Here mark is there. Are you observing here? Mark is there. Here mark. Up to this mark only we have to suck the FAS solution. Okay na? Up to this mark only. So this is called nozzle. This ending what we call this is a nozzle. See the procedure. Pipette exactly 10 ml of FAS solution into a conical flask. So this is conical flask. So what we have to do? 10 ml. So we have to suck this one. So just I am taking this FAS solution. I am keeping here. So don't keep this pipette up to here down, children. Okay na? So just at the bottom of this FAS solution, at the top layer only have to keep. Okay na? And see carefully, what do we call this finger? Index finger. So after sucking the solution, up to this mark only you have to suck this solution. Up to this mark only you have to suck this solution. And your index finger you have to keep here. If you are not keeping this index finger, again the solution will come down. Are you understanding? And one more thing, children, don't while sucking immediately it will go inside. Be careful. Why? Because in this FAS solution, constant H2SO4 is there. So be careful. Okay na? So anything will not happen, but something vomiting sensation or headache like that will get. Okay na? Be careful. Slowly you have to suck. Don't make hurry. Okay na? Slowly now I am sucking the FAS solution. So now look at here. What I told you. So index finger I have kept up here. Are you understanding? Up to the mark only should take. So just to see, I came down of the marker. So just again I am sucking. Exactly mark is there, no? Yes. Okay na? So now this exactly how much I am transferring? 10 ml. So 10 ml of FAS solution I am transferring into the conical flask. Clear? Exactly 10 ml. Don't take above the mark or below the mark. Exactly 10 ml only should take. Okay na? So this 10 ml I am transferring. So just you keep like this. So whatever is there in the pipette it will also come down. Okay na? So like that 10 ml solution you transfer. Clear? See the second point. Add half test tube. Test tube, give that one. So this is dilute H2SO4. Dilute H2SO4. Okay, are you observing? So half test tube. So this is the test tube. Half test tube dilute H2SO4 we add. So like this dilute H2SO4 half of the test tube we add. Okay na? Right. So like this half of the test tube we add. And this dilute H2SO4 transfer to this FAS solution. Clear? So transfer to this FAS solution like that to transfer. Clear? Now, okay na? So now you have to do titration against what? kmno4. So this is kmno4 solution. Okay na? So while doing the experiment, see readings you have to observe and you have to release this kmno4 drop wise. If you release this stopcock very fastly, solution will come down. Then again completely it will spoil. Again you have to do second time. That's why drop wise. And one more, while operating this burette, see carefully these three fingers. Three fingers, whatever is there, along with this thumb, this should be on the stopcock. And our conical flash should be on the right hand. So on the right hand conical flash should be there. You have to release drop wise. You have to release one drop. See, first of all, this is colorless. This is colorless. This colorless will change into pale pink. Where it will change a pale pink. Up to then you have to perform the experiment. Is it clear? So we are titrating it against kmno4 solution till colorless should change into pale pink. Colorless should change into what? Pale pink. Okay na? Now observe carefully. All of you look at carefully. So slowly, just one drop you release and slowly shake that. Don't release fastly. Just while releasing also, this should be near your side. So like this. So like this. Slowly. Observe here carefully. Like this. Suppose if this falls on the walls of the conical flask, just you make it shake like this. Okay, completely you make it dissolve like this. Suppose unfortunately if it falls on the walls of the conical flask, just you make it to dissolve. Okay, like this, just you make to dissolve completely. Okay, so slowly you make it to dissolve completely. Okay, so like that, slowly you have to make it to dissolve. Okay, now look at here, all of you. Look at here carefully. Look at here. Allow me look at here. Slowly, just a drop wise you release. Don't release fall. Just drop wise slowly. So like this you have to shake the conical flask. Okay, slowly. So when up to then we have to perform this experiment, still this colorless should change into what? Pale pink. Up to then you have to perform slowly. Just a drop wise only release. Okay, na? Suddenly it will change. Okay, na? At that particular point you have to note down carefully. Okay, na? So slowly I am just releasing drop wise. You can observe here only drop wise I am releasing. Don't release fastly. Change. Now observe here carefully. This also wherever it is there on the walls also just like this. This is pale pink children. Don't make pink color. You observe here readings. Observe here readings are there. See here from 0 I started. If you observe here exactly 1.5 km. I observe here readings I had observed here. That reading you have to note here. Look at here all of you. Fifth point is record the burette reading. Sixth one, repeat the titration for 2 to 3 times to get accurate titrate values. This experiment 2 to 3 times you have to do. See, one table is there. Their table is there or not? Burette reading, first one, second one, third one. 3 times you have to perform the experiment. First, initial reading is there. What is the initial reading? You have to keep the values. There you have given empty format. First you have to, what is the initial reading? 0. What is the initial reading? 0. What is the final reading? 1.5. 1.5 minus 1.0, how much? How much? 0.5. That 0 point difference you have to note down. You have to note down. Again look at here carefully. Again you have to start the second reading. Again we will not fill here kmno4. From here again you have to start the experiment. So that means for second time when we are doing initial reading will be what? 1.5. Final reading where it will come there you have to note down. And again third experiment. Again where we stopped, where we got pink color, from there you have to keep initial reading. Next final reading. Okay, na? Like that 3 times you have to perform the experiment. Okay, na? Last base see. Finally you have to find mean burette reading. Mean burette. Now we have to find the mean. We got the difference. First we have got, second one we got, third one we have got. 3 times we have got the readings. So that mean you have to take. Mean of first one, second one, third one divided by how much? 3. So you will get the value. This is the value of V1. What this is the value of V1. Now calculation see. What is the formula for this experiment is A1 M1 V1 is equal to A2 M2 V2. A1 A2 are fixed here. What are A1 A2 means? A1 A2 represent the oxidation numbers. Now already we have studied redox reactions. So redox reaction means what? Oxidation and reduction are taking simultaneously. Here also same thing. Why the color has changed here? Redox reaction has taken place between where kmno4 and FAS solution. Are you understanding? So here A1, A2 are fixed values. See already we have given there A1 is 5, A2 is 1. How we got 5 means in A1 if you observe kmno4 is there. If you observe in kmno4 potassium, what is the number? That is plus 7 for potassium. And manganese if you observe that is plus 2. 7 minus 2 it will become as 5. Similarly if you take other side FAS also, in FAS ferrous ammonium sulfate, Fe plus 3 will be there, Fe plus 2 also will be there. 2 types of ions will be there. So 3 minus 2, 1. So that are fixed values. So A1, A2 represented oxidation numbers. So that is fixed values in exam also. That is A1 is 5 and A2 is what? 1. And look at here M1 we have to find. We are doing this experiment to find the molarity of kmno4. So M1 question mark. V1 already we have got now. Now we have done 3 experiments. That V1 mean reading that you have to take V1 as. And M2 already we know how much solution. Now how much solution happens. This we will do. Manually we will prepare. So this is 0.1 molarity FAS. This we prepared. Okay na? So MD is 0.1 molarity FAS and V2 already how much I have taken in a pipette 10 ml. 10 ml FAS. So these are all fixed values. So you have to find by substituting these values, we will get what? M1 value. What will get the M1 value? So like this we will find the molarity of kmno4 solution. Molarity of kmno4 solution. Have you understood, children? So this is called titration. So we are titrating kmno4 against what? FAS solution. Against what? FAS. Be careful while performing this experiment. Starting reading should be 0. And while releasing this also, this is called stopcock. Slowly release dropwise. Dropwise only should fall. If you release fastly, again you have to perform the experiment. And by using while sucking the FAS solution, be careful that up to this mark only you have to suck that FAS solution. Don't suck fastly, it will go inside your mouth. In this already constant H2SO4 is there. So don't suck very fastly, slowly suck. Wash this upper layer neatly and suck this one. This is called what? Pipette. So like this we perform the experiment. We are having 4 models here. 4 models here. Thank you.